Today we are going to have a generating function for uh, the legendre polynomial. Okay, so we are going to have a generating function for legendre polynomial. The generating function is this: 1 minus 2xz plus z square to the power minus half. This is the generating function of the legendre polynomial, and we are going to prove this. Okay, so 1 minus 2xz plus z square to the power minus half, that is written as 1 minus z 2x minus z. Okay, I am taking z as common factor to the power minus half. Okay, now I am expanding this. Suppose I am expanding 1 minus x to the power minus half. That way we are expanding this, and we will get this 1 plus half z 2x minus z plus 1 by 2 into 3 by 4 z square 2x minus z square. The nth term, that is this 1 into 3 into 5, 2n minus 1, 2 into 4 into 6 divided by 2 into 5 into 6, 2n, z raised to n, 2x minus z to the power n. This is the nth term, and the previous term is this. Okay, so as we expand, we will be getting this. Okay, and the nth term is this. This is the nth term. Here we take the coefficient of z raised to n. Coefficient of z raised to n. Okay, so that is taken. The coefficient of z raised to n is taken in this term. We know as we expand something like this, a plus b to the power n, that is a plus b to the power n, that is going to be a to the power n, n a to the power n minus 1b, n in n minus 1, a 2 factorial, a to the power n minus 2b square, and the last term, you know, that is given by b to the power n. Okay, b to the power n, that is the last term. Okay, so the first term is a to the power n, the second term is n a to the power n minus 1b, which is basically nc1, then n into n minus 1 by 2 factorial, a to the power n minus 2b square. Okay, so we are going to use this Okay, so we are taking the coefficient of z raised to n in this expansion, and the first term, as you expand this, the first term will contain 2x to the power n. Okay, and the coefficient, since z raised to n is here, the coefficient of z raised to n will be this. Okay, 1 into 3 into 5, 2n minus 1, 2 into 4 into 6, 2n, 2x raised to n. Okay, so this will be the coefficient of z raised to n. in this expansion. Okay. So that I am writing like this. The 2 into 4 into 6. I'm taking 2 from each of these terms, and that will be 2 raised to n, 1 into 2 into 3 into n. That means the n factorial. So I'll have 2 raised to n here and a 2 raised to n from. So this will get cancelled, and we will be left with this 1 into 3 into 5 to n minus 1 and by n factorial x raised to n. Okay. So we will be left with only this. So this is the coefficient of x raised to n. Sorry, coefficient of z raised to n in that tape, only in this tape. Okay, only in this tape. Now the coefficient of z raised to n in this tape. Okay, as you expand this, there will be coefficient of z raised to n here, 2x minus z to the power n minus 1 into z raised to n minus 1. So there will be a term containing z in this expansion, and that will combine with z raised to n minus 1, and we will get z raised to n in the expansion, and we have to take that coefficient. Okay, so we are taking that coefficient. So that is given by coefficient z raised to n in this that we are going to take. As you expand this, you will be getting 2x to the power n minus 1, 2x to the power n minus 2 z. Okay, as this z combines with z raised to n minus 1, you will have z raised to n, and the coefficient is given by this. Okay, the coefficient is given by this 1, 3 into 5, 2n minus 3, 2 to the power n minus 5. If I am taking 2 from each of these, 2 to the power n minus 1, 1 into 2 into 3 to n minus 1. Okay, a minus is present. Now what we do is we introduce, here we have 2 to the power n minus 2, and in the denominator 2 to the power n minus 1. Okay, so we will be getting a 2 here, 2 to the power minus 1, that 2 comes here, and what we do is we introduce this here. We are introducing this here, 2n minus 1 by n into n by 2n minus 1. Okay, so as we introduce this, this will get cancelled. Sorry, as we introduce this here, we can write this as minus 1 into 3 into 5, 2n minus 3, 2n minus 1 comes here. Okay, this comes here, and in the denominator we have n factorial, this n minus 1, and that 1 into 2 into 2 into 3 into n, so n factorial, and the rest of the terms, n into n minus 1 by 2 to n minus 1 x to the power n minus 2. Okay, so this is what we get. Then combining, so we have got the coefficient of z raised to n, the first term that is given by this, the second term that is given by this. Okay, this is the second term. Okay, now we combine these two. Sorry, the second term is not this. Yeah, yes. So we get this. Proceeding further, we conclude that the coefficient of z raised to n in the expansion that is given by, if I take 1 into 3 into 5 to n minus 1 n factorial as common factor, I will have x raised to n here, and n into n minus 1 by 2 into 2n minus 1 x to the power n minus 2 here. So this is clearly Pn of x. Okay, we have written what is to Pn of x is. Okay, the legendre polynomial is. So this is clearly, this expression is clearly Pn of x. So what we did, we took the expansion of this 1 minus 2x plus z squared to the power minus half, and if you take coefficient of z raised to n, okay, if you take coefficient of z raised to n, what are we getting? We are getting Pn of x. So we can say the coefficient of z raised to 0, that will be P0 of x. Coefficient of z raised to 1 will be P1 of x, etc., etc. Okay. So the coefficient of P0, z0 of x, that will be P0 of x, and the coefficient of z raised to n will be P1 of x. So coefficient of z raised to 2, P2 of x. Z raised to n of x. And as you expand this 1 minus 2x plus z square to the power minus half, if you expand this, that will contain various powers of z. It will contain z raised to 0. It will contain z raised to 1. It will contain z raised to 2. Okay, z raised to 3. And the coefficient of z raised to 0 will be P0 of x. Coefficient of z raised to 1 will be P1 of x. This will be P2 of x. Okay, so one can write this expression that 1 minus 2x plus z squared to the power minus half is sigma n equals 0 to z raised to n Pn of x. Okay, that we can write. Okay, so this is the generating function, and from this we arrive at few results. One is Pn of x is Pn of x is equal to 1. Sorry, Pn of 1 is equal to 1. This is a result that we used previously. Pn of 1, that is equal to 1. How can we get that? From the generating function, 1 minus 2x plus z squared to the power minus half, that is equal to sigma n equals 0 to infinity z raised to n Pn of x, and here we put x equal to 1. Okay, so we have Pn of 1 here, and as I put x equal to 1, I will have this. And 1 minus 2z plus z squared to the power minus half. And see, this is 1 minus z square. 1 minus 2z plus z square is 1 minus z square. And to the power minus half here. So we have 1 minus z to the power minus 1, which is equal to sigma n equal to 0 to infinity z raised to n Pn of 1. And as we expand this, we have 1 plus z square z cube z raised to n, that is equal to P01 z P1 1. Okay, we are taking this expansion, and as we compare the coefficient of z raised to n on both sides, here as we compare the coefficient of z raised to 0, here 1, as we compare the coefficient of z raised to 1, we have p1 of 1, here 1. Coefficient of z square, p2 of 1, here 1. So we can say the coefficient of z raised to n, that is equal to 1. Okay, so pn of 1, we can say that is equal to 1. Because p0 of 1 is 1, p1 of 1 is 1. Okay, so we get such an interesting result. Okay, then we can move on to the next thing. We show that Pn of x, Pn of minus x, okay, Pn of minus x, that is equal to minus 1 to the power n Pn of x. Okay, we show the Pn of minus x is minus 1 to the power n Pn of x. It's very easy. We have the generative function 1 minus 2x plus z squared to the power minus half equal to this, sigma n equals 0 to z raised to n Pn of x. And we substitute minus x for x. Substitute minus x for x here. So we have 1 plus 2x plus z squared to the power minus half. And on the right hand side, sigma n equals 0 z raised to n Pn minus x. Okay, so we get equation 1, you can say. Now substitute minus z for z in this equation. So we have 1 plus 2x plus z square to the power minus half. And here we have my sigma n equals 0 to infinity minus z to the power n Pn of x. And this can be taken as equation 2. For equation 1 and 2, the left hand sides are same. They are same. And the right hand sides are equal. So as we compare the coefficient of z raised to n, we have Pn of minus x equal to minus 1 to the power n Pnx. Okay, it's an interesting result. Pn of minus x is minus 1 to the power n Pnx. See, this is different from the j and x. There we showed that j minus n of x. Okay, j minus n of x is equal to minus 1 to the power n Jn of x. So this is different from that. Okay. So we have this Pn of minus x equal to minus 1 to the power n Pnx. Here for x, if I put 1, so Pn of minus 1, that is equal to this. Pn of 1 we know, that is equal to 1. So we have Pn of minus 1 equal to minus 1 to the power n. Okay, so Pn of 1 is 1, Pn of minus 1 is minus 1 to the power n.